Hello students, today in this lecture we'll study the architecture of 8086 microprocessor. In previous lecture we have seen the pin diagram of 8086 microprocessor. 8086 microprocessor is a 16-bit microprocessor. It is Intel core microprocessor and available in 40-pin IC. Now architecture means 8086 having internal bank of registers and some ALU and pointers. So on your screen you can able to see the architecture of 8086 microprocessor. In previous lecture I have told you the 8086 microprocessor performs it execution in TASM assembly level language programming. So when we write any program in assembly level language, then this assembly level language is converted into machine level language, because microprocessor understands only machine level language, that is nothing but binary language, or we can say that zeros and ones. So there is need to convert the assembly level language into machine level language. The assembly level language is for user and machine level language is for machine or for processor. So it is necessary to convert assembly language into machine level language. So in this architecture all of you will come to know how this conversion is to be done with the help of different registers inside 8086. Now I have previously explained that while executing the instruction inside the 8086, each instruction goes under 3 cycles, that is fetch, decode and execute. Fetching means placing or setting address locations for given command. Then decoding means converting command, that is assembly language, into machine level language. And execution means according to user's command the 8086 performs the different operations, and after performing different operations some control signals are generated by 8086. So control signal generation is nothing but showing that execution of specific command is done inside the 8086. So the whole architecture is divided into two parts. First is bus interface unit and second is execution unit. So the right hand side part is bus interface unit. That means it consists of address 20-bit address bus, then address generation, then 16-bit data bus, then 4 segment registers, instruction pointer, bus logic control and instruction queue. So bus interface unit is used to fetch the instruction, read data from memory and input output ports, and write the data to memory and input output ports. Then second part is execution unit. At the left hand side you can see execution unit executes the instruction that they have already been fetched by bus interface unit. The execution unit consists of register bank, ALH or AX, BLBH or BX, CL, CH or CX, DHDL or DX, SP instruction pointer, base pointer, then DI and SI. Then it is also having 16-bit data bus, then some temporary registers are there, then ALU flag registers are there. Now we'll see the detailed explanation about each register. So in bus interface unit the address generation is done by one ALU. So what do you mean by address generation? So basically 8086 is having 20-bit address bus, and while we write any command, that will generate only 16-bit address. So we have to generate 20-bit address, that means physical address generation. So this physical address generation is done by code segment register and instruction pointer. So segment register is having 16-bit address, and it instruction pointer will provide 4-bit displacement to this, and this 4-bit displacement by instruction pointer and 16-bit address of CS is added together in address generation. In this way 20-bit physical address generation is carried out inside the bus interface unit. Then you can see that in orange color there are 4 segment register: code segment, data segment, stack segment, and extra segment register. Then what are these segment registers? This is nothing but the whole memory of 8086, that is 1 megabyte of memory, is divided into 4 segment register, that is CS means code segment, DS means data segment, SS means stack segment, and ES means extra segment. Whole memory is divided into this 4 segment register. Each segment is of 64 kilobytes, and each segment is having 256 address locations. Then we can access 256 bytes of segment register at a time. So large data processing is done inside the 8086. Then code segment register is basically used to store the code, that means assembly level language program, that is nothing but sequence of instruction, or you can say that code of particular task. It is stored in code segment register. It is a 16-bit register. As I told you, segment register will provide only 16-bit address, but the address bus of 8086 is of 20-bit, and we need to generate the address of whole instruction or whole command is of 20-bit, right? So we need again 4-bit address for total instruction. 8086चा जो ॲड्रेस बस आहे तो 20-बिट आहे, बट ज्यावेळेस आपण कोड सेगमेंट रजिस्टरमध्ये टाईप करतो त्यावेळेस त्याच्यामध्ये फक्त 16-बिट ॲड्रेस जनरेट होतो, आणि ॲड्रेस बसवरती 20-बिट ॲड्रेस बसवरती तो ॲड्रेस लोकेशन सेट करण्यासाठी 4 बिट कमी पडतात. तर ते 4 बिट आपल्याला ती डिस्प्लेसमेंट जी आहे ती आपल्याला इन्स्ट्रक्शन पॉइंटर थ्रू मिळते. सो 16-बिट ॲड्रेस is given by code segment register and 4-bit address is generated by instruction pointer, आणि ह्या दोघांची ॲडिशन होऊन टोटल 20-बिट फिजिकल ॲड्रेस तयार होतो. सो बस इंटरफेस युनिटमध्ये कोड सेगमेंट रजिस्टर आणि इन्स्ट्रक्शन पॉइंटर हे दोघं 20-बिट फिजिकल ॲड्रेस जनरेशनचं काम करतात. त्याच्यामुळे ॲड्रेस लोकेशन्स ज्या तयार होतात त्या 20-बिट असतात, आणि आपण त्या इझिली ॲक्सेस करू शकतो 20-बिट ॲड्रेस बस ऑफ 8086नी. देन जे 4-बिट डिस्प्लेसमेंट इन्स्ट्रक्शन पॉइंटर प्रोव्हाइड करतो, दॅट इज ऑल्सो कॉल्ड ॲज ऑफसेट जनरेटेड बाय इन्स्ट्रक्शन पॉइंटर. सो जी काय डिस्प्लेसमेंट असते त्याला ऑफसेट जनरेशन असं म्हणतात. ऑफसेट जनरेशन इज ऑलवेज गिवन बाय इन्स्ट्रक्शन पॉइंटर. देन डेटा सेगमेंट रजिस्टर, आपण जो कोड टाईप करतो त्या कोडमध्ये ज्या कमांड्स असतात त्या कमांड्स जेव्हा आपण राईट करतो तेव्हा काही 8-बिट किंवा 16-बिट डेटा आपण यूज करतो ऑपरेशनसाठी. तर तो जो डेटा आहे तो डेटा सेगमेंट रजिस्टरमध्ये स्टोअर केला जातो. सपोज एक इन्स्ट्रक्शन आहे ॲड A, B means add the data in register A and register B मग रेजिस्टर ए आणि रेजिस्टर बीमध्ये आयदर 8 बिट और 16 बिट डेटा असतो. तो डेटा जो आहे तो डेटा हा डेटा सेगमेंट रजिस्टरमध्ये स्टोअर केला जातो आणि ॲड ए कॉमा बी ही जी इन्स्ट्रक्शन आहे ह्या इन्स्ट्रक्शनचा कोड आणि ॲड्रेस हा कोड सेगमेंट रजिस्टरमध्ये स्टोअर केला जातो. सो जो डेटा आपण ऑपरेशनसाठी घेतो इन्स्ट्रक्शन्समध्ये कमांडमध्ये तो डेटा सेगमेंट रजिस्टरमध्ये स्टोअर केला जातो. डेटा सेगमेंट इज ऑल्सो ऑफ 16 बिट and while generating the address location for data segment register, the 4-bit displacement can be done by source index register, that is SI, and destination index register, DI. This 16-bit displacement is nothing but offset, which is used to compute 20-bit physical address. Then stack segment register. Stack segment register is nothing but stack pointer. It is used to push and pop operation. Means push and pop operation means loading किंवा इनपुट करणं म्हणजे पुश आणि पॉप करणं म्हणजे आउटपुट. सो डेटा जर आपल्याला इनपुट करायचा असेल किंवा आउटपुट करायचा असेल तर त्याच्यासाठी आपल्याला ॲड्रेस लोकेशन्स इन्क्रीमेंट करायला लागतात. सपोज we want to input data, right, and we want shift that data towards right or left side. जर आपल्याला डेटा इनपुट करायचा आहे आणि तो पुढे मागे मूव्ह करायचा आहे तर आपण पुश ऑपरेशन यूज करतो. तर पुश ऑपरेशनमध्ये ॲड्रेस लोकेशन ज्या आहेत त्या ॲटोमॅटिकली इन्क्रीमेंट झाल्या पाहिजेत. त्याच्याकरता आपण स्टॅक पॉइंटर वापरतो. आणि जसं मी सांगितलं पॉप म्हणजे काय की डेटा आऊट झाला पाहिजे. आऊट होताना इन्स्ट्रक्शन पॉइंटर हा डिक्रीमेंट झाला पाहिजे बाय 1 लोकेशन. सो त्याच्यासाठी स्टॅक पॉइंटर यूज करतात. मीन्स बाय युजिंग स्टॅक पॉइंटर वी कॅन पॉइंट नेक्स्ट मेमरी लोकेशन or we can point back into previous memory location. So stack pointer is used for this operation, pushing and popping. Then there are two pointers that is used in 8086, that means stack segment and base pointer. जसं तुम्ही सी प्रोग्रामिंगमध्ये शिकलाय तसेच पॉइंटर आहेत इथे स्टॅक सेगमेंट आणि बेस पॉइंटर. अगेन पॉइंटर इज यूज टू पॉइंट द मेमरी लोकेशन्स, right, previous and next memory locations. So this is the use of stack pointer, stack segment and base pointer for pushing and popping the operation of 8086. Then extra segment register, if we want to interface another peripheral devices or input output devices with 8086, then it requires extra amount of memory. So in that case the extra segment register, that is 16-bit extra segment register is used. Or if we want to use a large memory location inside the 8086, like for string operations, then extra segment register is used. It is also of 16-bit and this string instructions uses extra segment, and for that offset address generation is done by DI, that is destination index. Then instruction pointer, about this we have seen previously, that is in code segment register. Code segment register is of 16-bit segment register, so it will generate 16-bit address locations, and the 4-bit offset displacement is done by the instruction pointer. So instruction pointer is used to point next instruction to be executed within the currently executing code segment. This register contains 16-bit offset address. Then the next register in bus interface unit is instruction queue. Previously we have seen the instruction queue. Instruction queue of 8086 is of 6 byte in size. It is first in first out instruction register. Means जी इन्स्ट्रक्शन आपण पहिल्यांदी त्याच्यामध्ये लोड करतो तीच इन्स्ट्रक्शन पहिल्यांदा एक्झिक्यूट होते, त्याला आपण फर्स्ट इन फर्स्ट आउट म्हणतो. सो हा जो इन्स्ट्रक्शन क्यू आहे ह्याच्यामध्ये 6 बाईट ऑफ इन्फॉर्मेशन आपण स्टोअर करू शकतो. दॅट मच कोड इज एक्झिक्युटेड बाय 8086 ॲट अ टाईम. सो इन्स्ट्रक्शन क्यू सपोर्ट्स द प्रोसेस ऑफ पाईपलाईनिंग. मीन्स तो प्रिव्हियसली 6 बाईट डेटा स्टोअर करून ठेवतो. त्याच्यामुळे 8086 काय करतो, फर्स्ट इन्स्ट्रक्शन फेच करतो, दुसरी लोड करून ठेवतो. पहिली इन्स्ट्रक्शन फेच होऊन डिकोडला गेली की दुसरी फेचिंगला घेतो. देन पहिली इन्स्ट्रक्शन डिकोडला केली की दुसरी पहिली इन्स्ट्रक्शन एक्झिक्युशनला गेली की दुसरी डिकोडला घेतो. म्हणजे एका मागोमाग एक तो इन्स्ट्रक्शन्स ॲट अ टाईम फेच, डिकोड आणि एक्झिक्यूट करू शकतो. सो हे जे पाईपलाईनिंग आहे, दिस प्रोसेस इज कॉल्ड ॲज अ पाईपलाईनिंग अँड इट इज हॅपन इनसाइड द 8086 बिकॉज ऑफ इन्स्ट्रक्शन क्यू. देन एक्झिक्युशन युनिटमध्ये काय होतं ते बघायचं आहे. जसं बस इंटरफेस युनिटमध्ये सगळे सेगमेंट रजिस्टर्स अँड पॉइंटर्स जे आहेत ते 20 बिट फिजिकल ॲड्रेस जनरेशनचं काम करतात. द जनरेशन ऑफ 20 बिट फिजिकल ॲड्रेस इज नथिंग बट फेच प्रोसेस. मीन्स जनरेटिंग ॲड्रेस लोकेशन्स फॉर पर्टिक्युलर कमांड और कोड which is done by segment registers and pointers. This is called as a fetching process. Then after fetching, the assembly level language data is stored in instruction queue, and instruction queue starts converting this data into machine level language. That means execution unit, fetching and decoding is done, and the last process is execution, which is done by execution unit. Then in execution unit there is a 16-bit ALU which performs all logical and arithmetic operations. Then while performing the arithmetic and logical operation, the processor uses 8-bit and 16-bit data which is stored in general registers. So there is 4 general purpose register: AX, BX, CX and DX. So all these registers is of 16-bit. Also pointer registers, that means stack pointer and base pointer, is of 16-bit register. Then source index and destination index, DISI, are the index registers of 16-bit. Then AX register is the addition of AH and AL. So AH and AL can be used as a 8-bit registers individually. That means AH is 8-bit register and AL is also 8-bit register, and addition of these two is AX. That means it is a 16-bit register. So you can use AL or AH as 8-bit register individually, or you can use whole register, that is AX, as a 16-bit register. Likewise, BX can be used as a BH and BL, CX can be used as a CH and CL, DX can be used as a DH and DL. Then AX register is nothing but accumulator. Means all the operations performed by 8086, that is logical and arithmetic operations, the output or the result of these operations is stored into accumulator. So AX is accumulator. Accumulator means it stores the result of all operations, arithmetic as well as logic operations. Then base index register, BX, it is consist of BL and BH. So BL register is contains lower order byte of word, BH contains high order byte of word. So this is used to used as a 16-bit register. Then CX is used as a counter register. All of you know about counter. In digital technique we have learned about counter. Counter is a series of flip-flop which is used to count the clock pulses. Here the register CX is used as a counter whenever we required counting or shifting or rotate instruction or loop instruction. Counter register CX is used. Then data register DX, it is used to hold the lower order as well as higher order data. So it is called as a data register. It performs division operation, or we can store the dividend or multiplier in data register. Stack pointer and base pointer, as I said you, the pointer is used to point the next memory location. So push and pop operation is performed by pointers. We have two pointers in 8086, that is stack pointer and base pointer. These pointers are same like you have used in C language. So the pointer is used for push and pop operation. Then source index and destination index register. These registers always supports the extra segment register, because if we want to perform long data bit operations like strings, in that case we required extra segment register. So in extra segment register the SI and DI is used to generate source and destination index strings. So these index registers are useful in string or long data bit operations. Then when ALU performs different type of arithmetic and logical operations depending on data, 8-bit data or 16-bit data which is stored in 8-bit or 16-bit register, then after performing the arithmetic and logical operations, the 8086 generates control signals. These control signals are generated by flag register. So flag register will show you which type of control signals is generated by 8086 after performing arithmetic and logical operation. So flag register is 16-bit register. So on your screen you can see the structure of flag register. It is a 16-bit register. So first bit is carry flag. So if we perform addition subtraction operation, then carry flag is set in case of addition, and if if subtraction is done, then borrow is set in this flag. So after performing this addition and subtraction, if there is a generation of carry or borrow, this flag will set to 1, otherwise it is in 0 position. Then parity flag. Parity means number of zeros and ones, number of ones present in produced output is nothing but parity. Means if the output is produced like 0 1 1 0, then in 0 1 1 0 the number of ones are 2. That means the output is having even parity. And if the output is 0 1 1 1 0, then the number of ones are 3. That means odd parity is generated. So the parity is nothing but number of ones present in the output. And if parity flag is set, that means if it is at 1, then parity flag is set, that means even parity is generated, and if odd parity is there, then this flag is set to 0. Then auxiliary carry flag. Auxiliary carry flag is set when there is a subtraction operation is performed, and in that case if borrow is generated, then this flag will set to 1. Then 0 flag If we perform some operation or computation, then if the result of operation is 0, then this flag is set to 1, otherwise it is reset to 0. Then sign flag, after performing the operation, if result is negative, then sign flag is set to 1, otherwise it is reset to 0. Then trap flag means it is in this flag indicates that interrupt request is executed by instruction. So trap flag is used to indicate that interrupt request is executed by microprocessor. Then interrupt flag, this interrupt flag is used to recognize the interrupt is maskable or non-maskable. This concept we have learned in pin diagram, that is NMI pin. When NMI pin enables, it indicates that the software interrupts will be executed by 8086. So interrupt flag recognize the maskable and non-maskable interrupts. Then DF means direction flag. If some transmission and reception of data is done inside the microprocessor, then if you want to shift data, so that data is shifted in some particular direction. So when we set this direction flag, so it indicates that how data is processed after execution, that means serial in serial out or parallel in parallel out. In that case direction flag is set. Then overflow flag, if some operations are performed inside the 8086, the long data is generated after execution of some commands, then sometimes long data is recognized by overflow flag, and if the operation is having long data, then overflow flag will set. This is all about the architecture of 8086. Once again we'll see the size of register and use of register. The general purpose register are, if general purpose registers are 16-bit, then they are AX, BX, CX and DX. If they are used as a 8-bit, then they will be ALH, BLBH, CLCH, DL, DH. Pointer register, we are having two pointer register, that is of 16-bit SP and BP. We have two index register SI and DI, which is used for string operation. Then instruction pointer, it is of 16-bit. All the pointers are used for push and pop operation. Then we have 4 segment registers, CS, DS, SS and ES. The whole memory of 8086 is divided into segment register. Each segment register is of 64 kilobytes and it is having 256 address locations, and we can access all these 256 address location at a time. Then flag register, 16-bit register. Then we have 16-bit accumulator, which used to store the result of all operations performed by ALU. Then AL is a 8-bit accumulator. Then BX is a base register. Then CS is a counter register, which is used for shift, rotate and loop operations. Then DX is data register, which is used to store multiplication and division operation. Then stack pointer, it is used to hold the stack or offset data. Then base pointer, it is also 16-bit pointer, which is used by stack memory. Then source index and data index register, these two index registers are used for long data operations like string operations. So this is all about the architecture of 8086.